At that point, just use the raise hand option in Zoom. It's underneath reactions to let us know you have a question, and we'll get to you. But yeah, let's just go through the content. Let's share some awesome knowledge about tech interviewing. Okay, so starting us off, I want to talk about the mental game. So I think a lot of people with interviewing, they focus on the very kind of tactical stuff. They focus on, oh, how do I do Alien Dictionary? How do I understand how dynamic programming works? They focus on these kind of nuts and bolts type things. And of course, you have to get good at these in order to pass the data structures and algorithms portion of your tech interview, especially for a big tech interview. But what I think is not talked about nearly enough is the mental game. So in order for you to go through this long, laborious process of studying data structures and algorithms, and then learning all these like crazy patterns, and then actually going into the interview and perform during these rounds, like you have to have a good mental game. You need to have the proper mindset. You need to have the proper mental framework so you can stay mentally healthy while you're doing all this preparation, which is why for this presentation, we carved out a section where we're going to talk about this aspect in particular, about how you can stay mentally healthy while going through this process, because this is essentially the foundation upon which you learn all the tactical stuff. Like without this, you will not be able to continue doing leak code for 1, 2, 3 months. So yeah, the first thing I want to go over is progress is exponential. I have talked with many people in the community now, like often directly, and pretty much everyone tells me like, Alex, I feel like I'm doing something wrong, because like I'm doing this like data structure and algorithm stuff, and I feel like I'm not making progress. Like I've been working at it for like 1, 2, 3 weeks now. I'm having trouble with pretty much every problem. Even LeetCode easies are like are just destroying me. Like, am I just not cut out for CS? Am I not cut out for software? And for all the people out here who feel like this, and I'm sure a good amount of people on this call feel like this, I just want to say it's completely normal. It's completely normal. Like data structures and algorithms is not really like a natural thing. It pushes your thinking in a way that your brain is probably not used to. And to really like drive this point home, this was me. This chart right here, this was me. So I really started getting into data structures and algorithms when I was trying to get into Facebook, which was about 4.5 years ago. And this was my process getting into Facebook. I got LeetCode, and then I was like, all right, I'm gonna do a bunch of LeetCode problems, because my first 2 jobs, PayPal and Course Hero, I got kind of lucky. I didn't really study DSA that much, but I was able to get those offers. But I knew that wasn't going to be the case with Facebook and just big tech in general. I was like, okay, I need to get good at this, otherwise I'm not going to pass. So I did LeetCode pretty much every day for 3 months. I did an average of 2 to 3 hours of studying per day. And I went through probably around 150 to 175 LeetCode problems, alongside doing a bunch of other problems from like Geeks for Geeks and stuff I found on Glassdoor, etc. For the first, I would say, month and a half to 2 months, I felt exactly like what I just described before. I felt like I wasn't making any progress. I remember when I first started doing LeetCode, I couldn't do any of the easies. Like I would just open up like any LeetCode easy problem. And just for context here, LeetCode splits up problems into 3 different tiers: easy, medium, and hard. And easy is supposed to be problems that like most people should be able to get in 10 to 25 minutes, supposedly. But I couldn't figure out pretty much any of them, and I felt really, really stupid. But over time, what happens with my DSA, like studying for Facebook, and I think most people's as well, is you hit something called an inflection point. Essentially, you're going to feel really, really stupid for a long time. For a long time, like probably 50 to 70% of the process, assuming you make it all the way to the end, which is where you feel like you have pretty good mastery, which probably will take at least 2 to 3 months plus for the vast majority of people. You're not going to feel like you're making progress. So you can see here the line is like not that curvy for the first half or so, but then you're going to hit a point where like all the hard work that you've done starts paying off, and all the pieces just start like coming together. It's like hard to describe. It just happens. And I think that was the case like after 2 months for me. So like in the last month of me studying for Facebook, in that last third, like my mindset just like quickly changed, and I was able to go into pretty much any problem, any easy or medium problem at least, and some hard problems. And I felt like I was like Neo in the Matrix, because like everything just started coming together, and I could be like, oh yeah, this one, I just have to do DFS on it, or like this one has like this DP solution or this has some sliding window. And I was able to like solve most of the problems without a bunch of hand holding. I didn't have to open the answer or look at the discussion threads. I could actually like solve the problems on the fly, and it felt amazing. So just wanted to let everyone here know is when you go into this DSA process, you just have this in mind. So when you feel dumb in that first portion, just know it's completely normal and things will get better over time. Trust me. Like pretty much, I would say 90 to 95% plus of people are going to follow this learning curve here. Yeah, Rahul, anything to add?
Yeah, if there's one thing that I want people to take away from this presentation, it's this slide that Alex put together, which is that you have to trust the process. So there's a broader discussion here around, like, are DSA questions actually a good way to assess the competency of an engineer? And I think you could make arguments yes and no. But there is one thing that data structure and algorithm questions have going for them, which is that it's fairly methodical to get better at them. And let me illustrate this by talking about something which is where it's not methodical to get better at it, right? Like, let's say that my goal is to build a startup, right? I want to build a VC-backed startup, which is going to impact a lot of people, and I'll make a bunch of money and all these things that come with a startup. And so then you could say, okay, well, in order to achieve that objective, one thing I'm going to do is on GitHub, you know how if you commit code on GitHub, you have that like green square show up? If you know what I'm talking about, give me a thumbs up on Zoom, give me a reaction. And so you can say, okay, what I'm going to do now is every single day, I'm going to commit a piece of code. So I'm going to have like this really long GitHub commit streak, and that'll be how I achieve my mission of building a startup. But that is a big disconnect there. That's my point, is the fact that there's so much that happens in building a successful startup that cannot be measured by you committing code every day on GitHub. But contrast that with data structures and algorithms questions. There's a purity, or there's a much more methodical way to get better at DSA, which is just do more of them. There's no other, it's kind of like running a marathon. I mean, it's kind of a weird analogy for me to talk about running a marathon because I've never ran a marathon before. But like with running a marathon, just run every day. There's no secret. There's no magic. Just run every single day and you will be able to run a marathon. I promise you. And so I think that's really what I think this graph illustrates, is that trust the process, trust the system, and you will get better every day. And you'll get to the point where you're going to be passing the majority of these interviews. The last time, about a week ago, or I think it was like a week and a half ago, Alex and I had a session about time management. And one of the things I mentioned in that session, that the system is much more important than a particular day or a particular outcome. That's exactly, I think, another way of framing this, which is that if you feel like you messed up today, like you didn't get any leak code problems, you messed up tomorrow, you messed up next week, it doesn't matter. Just trust the process, have blind faith in your system, and you will achieve what you want. So I think this is probably the most important slide, I think. If this is one thing you want to take away, then this is what you should take away.
Yep, for sure.
All right.
Moving on, we can talk about motivation, which is another question that that Rahul and I have gotten a ton, especially in our Slack community, and just is, I think, it's something important to really be able to maintain in general. So a couple tips about motivation, but I think the first one is Rahul and I are nerds, so we use math a lot. Mathematically, doing data structure and algorithms preparation, especially if you have a big tech interview, is one of the best return on investments you can get. Like for pretty much all humans on this earth, like think about all the things you can do where you can like put in some amount of time and then get some amount of benefit, like in particular, like, money, compensation. DSA preparation is like probably within the top 5% or 1% of opportunities. And I actually have some anecdotal evidence here. So when I made the jump from Course Hero to Facebook, as mentioned before, I did 3 months of leak code preparation. And as the previous slide shows, it wasn't entirely all fun and games. In fact, it was quite not fun for the first, month and a half to 2 months, because I felt like an idiot. I was going through these problems. Progress came painfully slow. I didn't really feel like I was going anywhere. But I knew that if I was able to, I had the interview lined up already. I just had to pass it. I knew if I could pass the interview for Facebook, things would get a lot better. And like, let's zoom out here. So I studied every day for about 3 months. Let's say we did like 2 hours like per day on average, because some weekend days I didn't study. Across 3 months, it's like 180 hours, like 175 to 200 hours, right? But, and I'm gonna drop some like concrete numbers here, I was able to increase my compensation by 50% after I was able to get into Facebook and leave Course Hero. Ended up being around a $70,000 to $80,000 increase in my compensation for around 175 200 hours of work. Like I ended up making like 75K more per year, which is like absolutely insane. And it's not just the money. Of course, the money is really important. The thing about getting into big tech in particular is that your entire like job outlook also changes. So number one, like the folks at big tech are the best of the best. Like there's a reason why these companies are so successful. It's because they legitimately just hire amazing people all the time. And once you get into these companies, you can learn from them. And the next point is job searching becomes so easy after you make it into big tech. So I'm sure a lot of folks here, like Rahul and I have, done a lot of kind of demographic analysis, and most of the folks in our community are junior, which makes sense because like if you need advice level of your career in tech, junior folks are going to need it more. So junior folks are used to the world of they have to apply for everything and struggle. They have to apply online, cold message. They're just sending this time into a black hole and hoping something comes out of it. This will completely flip if you get into big tech. Like you don't have to send a single application after you get into big tech. You don't have to cold message a single person anymore because the jobs will come to you. Everyone wants to hire the people who worked at like Amazon or Google or Facebook. The recruiters will come to you. You don't have to you don't have to like go to them anymore and just cross your fingers and hope you don't get ignored. That completely goes away. So just keep all these things in mind when you're doing DSA prep, especially for big tech, because like as I mentioned before, the math does check out. And like I think that like the payoff here is just absolutely ridiculous. There are very few opportunities in the world that can match this. Yeah. And Rahul, you want to do this one?
Yeah, I can take a stab at this. So I think the other big thing about motivation, this is again kind of connecting it back to our time management session from last time. Social accountability is extremely powerful. When you tell a friend or a family member that I'm going to do something and then you don't, shame, it's like you really want to avoid that feeling of shame, and that fear is a powerful motivator. And so I feel like if you're having a hard time grinding out LeetCode, find a friend and do it with them. Like put on a Zoom video chat or whatever, and do it together. Or a better way is to do a mock interview, right? So I think mock interview, the density of how much you're getting out of each question might be a little bit less, but it is going to be much closer to the real experience. And that is something that I think a lot of people miss when they're writing out their code on their IDE on their computer, but they're not actually talking verbally. They're missing a big part of how they're actually going to be evaluated by these big tech companies. And so I feel like finding a friend and actually doing a mock interview will give you a whole other dimension of preparation.
100% agree with that. I'm dropping links to the Slack community just now, just as a reminder. You can use our Slack community to find a friend and share it with YouTube.
Yeah, that's a good call. We recently installed this bot called Donut on Slack, which like pairs people up. So we've been experimenting with different ways to get people to find their mock interview friend.
Yeah, and it's been pretty awesome. Like I've had numerous people ping me on Slack, letting me know, like, hey, this, I've been able to find a buddy through this community, and we're doing like DSA. I think most buddies are for DSA, and it's been really heartwarming to see that happen. Yeah, if there's something that you got to find a buddy for in tech, is like DSA is one of the top things. As mentioned before, it's such like kind of a soul crushing experience. It's not really worth. It's just a terrible experience going through it by yourself. But yeah, anyways, let's move on to some other tips, which I was unable to fit into a coherent category for all of them. So yeah, so the first one is turn it into a habit. When it comes to stuff like this, these kind of like things that frankly feel more like chores, and people just naturally don't enjoy doing. You want to do a little bit of it every day as opposed to a lot of it all at once. Like coding is something I would recommend, like going and like trying to build a flow state, and you want to have like 4 to 8 hour blocks where you just write a bunch of code. That is not the case for LeetCode. You're just going to get so frustrated, your brain is going to die. So It's quite similar to, I think, exercise for a lot of people. So when you take on your DSA journey, I would just try to commit to doing something like at least 30 to 45 minutes of prep at least 3 times a week, something like that. And the good thing about building habits is like once you build the habit, it's eventually going to come like naturally for you. You're gonna be like, oh yeah, like this is my DSA time because I've already been doing it a couple times a week for the past like 3 weeks now. So yeah, building the habit in the beginning is hard, but then it gets easier over time. Similar to DSA as a whole. Yeah. Next piece of advice is take frequent breaks. Yeah, as mentioned before, like DSA is just naturally not enjoyable. It's quite painful. This is the kind of stuff where you got to give your brain some relaxation time. So my ratio is for every 2 hours of work, I take 30 minutes of break. So I'll watch something on like an episode of something on Netflix, or I watch some YouTube, or something fun. Yeah, feel free to adjust as you wish, but yeah, take frequent breaks because to keep your mind like fresh. You're essentially running a mental marathon here, doing DSA, tying all the metaphors together. Oh yeah, another one is don't cram. It's just, I think cramming in general is not very good. This is something I learned the hard way all the way back in high school. Generally, what I've seen happen when you cram is like your goal is like, oh man, like I have, there's like 100 things to memorize. And then I just want to make sure I have all 100 things memorized, particularly like these 20 things I feel like I haven't super memorized. What I've found is that since you're putting your mind into such a frantic state by cramming, when you get to the actual thing, like whether it's a test in high school or the actual interview, if you see something that's outside of what you crammed, you are going to fail it because you are taking away your mental nimbleness, and you're making yourself very fragile. So yeah, your cramming will make you better at having memorized like these particular solutions. But if a problem falls outside of those solutions, then you're just completely dead. And that's the mindset cramming puts yourself into. So it's just really not worth it to cram because when it comes to big tech DSA interviews in particular, it's going to be very unlikely that like you just have seen every problem before. Like you're almost certainly going to get a problem that you haven't seen before. So you absolutely need your mental state to be very flexible and nimble going into it. So yeah, just don't cram. It's just not worth it. Okay, this one's a bit tricky. So of course, for DSA and big tech, you have to study a lot in order to pass. They're just like a DSA, they pretty much every big tech on site, you'll probably get at least one like LeetCode hard level problem, like a final boss type problem. So you got to make sure you study, you build that DSA muscle quite a lot. Care a little is something I want to explain about a lot more. So just to harkening back to my earlier days as a junior engineer here, essentially, if you look at my career trajectory, like how long I've been working, and then my passion for interviews, like in the beginning, my passion for interviews was like really trash, and then it like went really high over time. But I did so many interviews as a UCLA student trying to get a job that I essentially flipped my mindset around interviewing. So it's kind of a mix of like realizing I needed to flip my mindset, plus I just kind of had to because I was failing so much. So what I realized was if I went into these interviews and saw them as a make or break opportunity, um, like it wasn't really healthy for my mental state overall because, make or break means like, if I pass this interview, I'm going to be super happy and I've made it and my life will completely change for the better. And then, if I fail, it's broken, like my career is broken. I suck. And, I did a terrible job and I should feel bad. If you have this mentality going into interviews, especially earlier on where you're going to fail most of your interviews, like you're just going to get so like depressed so fast because like every single interview fail is going to just like completely tear you down. And this job searching stuff, especially kind of getting big tech, it's a marathon, not a sprint. You can't set up your mindset in a way where if you fail an interview, you just completely break down. You're not going to be able to get to the next one. So what I ended up doing was I ended up flipping my mindset about interviews. Instead of going into interviews like, oh man, if I don't get this, I'm going to feel so sad because like, I could have made my career in this case, but I didn't. I went in seeing them as an opportunity to just hang out with some smart, cool tech people and just like chat a bit. And then if I happen to get a job offer out of it, then that's cool. But then if not, then I mean, that's okay. There's more interviews. So I essentially went into interviews like caring less about them, which I know is a bit counterintuitive because it is true that if you pass an interview, especially a big tech interview, your life does change dramatically for the better. But like if you focus on that, like during the interview, you're you're just going to have so much anxiety that, again, that like mental flexibleness and nimbleness is just not going to be there. So yeah, it's a bit weird, but like the less you care about the interviews going into them, the higher the chance you have of performing in them and passing. Because the more relaxed you are, the more nimble you are, and the more nimble you are, the better you will be at solving those problems. Yeah, Rahul, anything to
Yeah,
add here?
I think that last point is critical. The way I like to think about it, and I mentioned this in one of my previous YouTube videos, is be input driven, not output driven. And the reason you want to adhere to that as a life philosophy is that you can control what you put into a system. You can control like how much effort you're putting in. You can control, this idea of I'm going to do 1 hour of LeetCode every single day. You can control that. But what you cannot control is you getting an offer, right? There's so many things that, like your interviewer might be having a bad day, or you might have just gotten a really hard question, like an unlucky question, right? Like there's so many things that aren't in your control. But what you can control is how much you study. And that's exactly what that bullet point is saying. And one more thing I want to also mention is around the take frequent breaks and turning into a habit. That is also critical. This is not just me and Alex anecdotally talking about what worked for us, although that did work for us. But there's also a really strong scientific basis for this. It's proven that if you do tactics like spaced repetition and repeatedly attacking the problem, or like a concept over time, you will retain it with much higher likelihood compared to if you just did that same amount of effort in a compact amount of time. And so rather than approaching it as like, I'm going to spend 6 hours on a Saturday or Sunday doing LeetCode, it's way better, and you're going to perform much better on DSA if you can split up those 6 hours and do it like 1 hour every day.
Okay, so now we've talked about the mental game. We can move on to the actual concrete preparation, and we can start off with talking about the tools. So there's a billion tools, and it would take hours upon hours upon hours to go through all the good tools. But in the end, people come to these sessions to hear Rahul and I's opinion. So we're going to give you our pretty opinionated take on what we think are the best tools. So number one, by far, at least in my opinion, I don't know about Rahul, is LeetCode.
I agree.
Yeah, LeetCode is kind of a titan of this industry. It's been around for as long as I can remember. Like, I think when I was a freshman at UCLA, it was probably already there in some form. Probably had much worse UI UX, but it was there. For those of you who haven't used LeetCode before, it has a huge repository of problems. I think 1,000 plus now at this point. It essentially gives you the problem, and then you have a code editor, so you actually get to write the code. It pretty much supports every major language, at least 10, 15 different languages. So you'll be able to code in whatever language you want, and then you get your test cases, you get your method definition, you write the code, and then you run it, and then it'll compile, build, and it also profile it. It'll tell you like, oh yeah, your solution was like 70, faster than 70% of other solutions, or 50% or 100%, which is useful because, generally in big tech interviews, you want to get the optimal execution time, optimal runtime, the optimal big O. So on LeetCode, if you're able to get a solution that's faster than most other solutions, you've probably gotten the correct big O. And side note here, this is especially true for big tech, is buy LeetCode Premium. So LeetCode Premium, it's I think $35 a month. Which sounds like a lot. It's like 3x an Netflix subscription, but like it's super, super worth it for big tech because of, I think, one feature, company tagging. So once you get premium, you can you get a frequency like chart of like how often like companies ask certain questions. So like, oh yeah, like Amazon asks like this LeetCode problem a lot, or Google asks this one a lot. And then you can essentially target your studying. So you can try to cover the problems that the companies will more likely ask you during the interview. And I think this is because there's no way you can do all 1,000 problems. So you need to know like which problems to prioritize. And if like, again, the math checks out. Like, let's say you get premium and it only increases, quote unquote, only increases your chances of passing your big tech interview by 5%. Like, it's really hard to have a concrete number, since it's like, you earn a recurring salary at a big company, but like 5% of like a 6-figure job, that's like thousands upon thousands of dollars, right? And you only need LeetCode Premium for maybe 2-3 months. That's $70 to $105. That's totally worth it. And then to add some context here is for big tech, generally at the first round, like the phone screen. The definitions are a bit blurrier now since it's all remote, but yeah, on the first round, you'll get a combination of easy and medium problems most of the time. If you get a hard problem on a phone screen, then you probably just had an interviewer who's had a bad day. And then on the final round, the round of like 4 or 5 different interviewers that you have to pass to actually get the offer, you'll generally get a collection of medium and hard problems for LeetCode. So yeah, LeetCode is, I think, pretty much like the standard in the industry. Like you'll see people using these difficulty levels to describe, like how the interviews work. So yeah, if you haven't used LeetCode and you feel like you could get a boost in your current, whatever tool suite you have, you should definitely use it. It's an amazing tool. The second tool I want to talk about is Glassdoor. Glassdoor, for those of you who, if you haven't used it somehow already, it's essentially a crowdsourced community around company data. And one of the things they report on companies is interview data. So people will go on and be, oh yeah, I did an interview with like XYZ companies. This is how it went. These are the questions I got. So with any crowdsourced thing, the more data you have, the better, obviously. And big tech is big, so it has the most data on Glassdoor. So Glassdoor is extremely, extremely valuable resource when it comes to like big tech interviews. And my philosophy is, if you go on Glassdoor and you go through the recent interview like blurbs, like past 2-3 years, if you see a problem that's been mentioned at least 2 times, you should just know it. You should know how to do it, because like if you get a problem that was on Glassdoor and you fail it, like, oh, you're gonna kind of have no one to blame but yourself, and you're gonna feel terrible. And this is exactly what happened to me. Like, again, I have anecdotal evidence here. Back in 2015, as I was trying to leave PayPal, I actually interviewed for Google. And I was lucky enough to make it to the onsite. And there was this problem that I got completely destroyed on, to the point where like the interviewer had to spoon feed me the answer pretty much, and I still couldn't completely do it. It was awful. And I found out like a few days later that this problem was on Glassdoor. Like there were multiple people who were like, oh yeah, I got like this LeetCode problem during my Google onsite. And I was like, oh my God, if I had just looked at Glassdoor, then I would have been prepared for this problem and I wouldn't have gone trashed, and maybe I would have gone to Google after PayPal. So yeah, please use Glassdoor. Like it's such a great resource. It sounds obvious, but there are so many people, like it's surprising to me that a lot of people don't even like look at the Glassdoor for interviews, which is, I think, just wrong. Yeah.
One more tool I want to mention is cracking the coding interview. So like when I was starting out, I actually, similar to what Alex mentioned, I'm not even sure, I'm forgetting when I first even learned about LeetCode, but it certainly wasn't when I first started doing technical interviews. I think the main resources I used back then were cracking the coding interview. And there was something called Project Euler, which I don't think people actually use anymore. But I like cracking the coding interview, that book, because it's actually there's not as many problems available. And I think sometimes not having choice makes your life a little bit simpler. So I literally went through almost every question in that book, just because it was actually more feasible. Compared to LeetCode, there's no way a single person can get through every question in a reasonable amount of time. So I think I'll just plug cracking the coding interview if people prefer that. And also like having the physical book. I might be old fashioned, but I like having that physical book as well. And then the next thing that a lot of people will ask about is, I'm given a coding question, what programming language should I use to implement the solution? And there's no right answer here, but in terms of opinions that Alex and I have, I think if you had a choice, then try and pick a more concise language like Python. And the reason is simply because time. You have tech interviews, coding interviews are a very artificial environment where you have 45 minutes or 1 hour to be able to actually output sensible code that works. And if you're writing a more verbose language like Java or C, then you're essentially wasting time writing out things on the whiteboard which don't have that much value, rather than communicating to the interviewer that you understand these concepts and you understand how to put code together. So definitely, if you have awareness or knowledge of something like Python or Kotlin, which is definitely more concise, and use that. The other question that we often get around programming languages is that I know this rare language like Prolog or Erlang, should I use that one? Or maybe I'll look more impressive if I use a language that the interviewer doesn't know. And the answer here is no. Try and stick with the canonical set of languages like Python, Kotlin, Swift, these things that most people have heard of and are familiar with. And the reason is, again, going back to this idea of time. You have 45 minutes to convince the interviewer that you're able to write solid code, high quality code. And if you're spending 5 or 10 minutes explaining some part of the language that the interviewer may not be familiar with, that's essentially time wasted. I mean, it may not be 100% time wasted because you could eloquently describe it and the interviewer could be impressed with your ability to explain things. But unless you really feel like you're an expert in that language, I would stick with the common set of languages that most people are familiar with.
Yeah, and I actually have another anecdote here. Again, just like bringing examples from my life of like what not to do. In this case, it actually wasn't me, but a good friend of mine who was my college roommate. Back, at least when I was at UCLA, they started us off with C++ and C. So we first learned C++, and then we eventually pivoted to C as our main language. For those of you guys who haven't written C and C++ before, they're extremely verbose. Like something that would take like 2 lines of Python would probably take like 15 lines of C. So my college roommate actually had a phone screen with WhatsApp, amazing tech company, eventually acquired by Facebook. I'm sure we all know what WhatsApp is. And he got, a LeetCode problem as expected in the phone screen, and he knew the solution, but he couldn't physically code it out in time in C because, he was using C because like C was our main language at UCLA. So since he wasn't able to just get a working solution like physically, he ended up not passing the round despite knowing how to solve the problem because the language was holding him back. So yeah, I think most languages are okay, but yeah, there are a couple outliers like C where it's just like you just physically won't have enough time to do the problem writing in this language. Okay, now moving on to actually learning the material. I think the core piece of advice that we have here is that DSA ultimately becomes an exercise in pattern recognition. So, and this is like part of the inflection point that I mentioned before, like when you kind of get the matrix vision and you realize like what you've actually been doing all along. So once you like hit the inflection point, you'll realize that like, I think I would say at least 75 to 80% of problems fall within 10 to 15 common patterns. Like sliding windows is a pattern, and then just like tree searches like DFS or BFS, those are also patterns, tails and recursion. So your mindset going into problems, like if you see a problem that you've never seen before, is just start cycling through the patterns in your head. Just be like, okay, I can use a tree to solve this. Can I use like a linked list? Can I use tails and recursion or something? So because you're like doing problems, just make a note of like, okay, what pattern did this solution end up falling into? Because there's no way that you can memorize like 100 to 150 to 200 individual solutions to problems. Like I know that a lot of like folks when they're in school, and I think like a lot of schools in Asia in particular, like focus a lot more on this kind of drill and kill memorization method. I don't think that works with DSA. It's just not scalable. Just like memorizing everything, it's much more scalable to memorize patterns than to memorize individual solutions. Yeah, and then something that I found helpful was to extensively comment your solutions. So you're generally going to solve the problems, and you're going to go back to them at some point just to refresh your knowledge. If you don't comment your solutions, you're going to end up going back to the problem that you solved and like not knowing how you did it. So this is essentially how I prepped for Facebook. Whenever I solved a problem, I would write like some amount of comments at the top of the problem, essentially explaining like how the problem works in as plain English as possible. And drawing back to the prior point, I would try to identify the pattern. I'd be like, okay, this solution requires like, a heap or something. Like that's the core pattern that solves this problem. And this is also like a good like resource going like when you comment your solutions, and in general, when you write stuff down, it's much better for learning, right? I think it's something like if you just read something, your chance of retaining it over like 1 or 2 month period is only 5%. But like once you write it down, it shoots up to like 15, 20%. So after you solve a problem, like in order to really solidify like a true learning of it, just like write down like how you did it. Because like, again, you can't memorize the code. People don't remember code. you write code, you don't remember code. It's so long and like complicated that you just can't physically remember it. Yeah. And then I think the next one is interesting, but this is essentially what I ended up doing from preparing for Facebook. And this is kind of harkening back to the prior concept of like being flexible and like building the muscle of filling in the gaps and connecting the dots together. When you are looking at a problem and you just can't, you can't figure it out, what I recommend doing is don't just give up completely and then there's like look at the answer and read the entire answer. So generally on LeetCode, you have like, you can go to the answer, like discussion and answer section, and then people will have the entire code snippet of what worked for them and then explain it in great detail. Don't just give up and just read that entire thing. You want to go back to building the flexible and nimble muscle. So when I was unable to solve a problem, I would go to the solution, and then this is a bit tricky because it's all on one page. I would only read the first line or two of them explaining their solution. I would grab that and then go back to my coding window and put that in. So I'm essentially not giving myself the entire solution. I'm only giving, like 10 or 15%. That essentially high level description of like how the solution works, and then trying to build the muscle of, can I convert this like 1 or 2 liner into a functional solution, which is the next point. So essentially the process is, especially if you get a problem on the interview that you've seen before, like you're not going to be able to know the entire solution line by line. And that's also pretty unhealthy anyways, because if you regurgitate the entire solution perfectly line by line, the interviewer is not going to get much signal on your ability. They just know that you've memorized it, and they'll probably make you do another problem. But if you only know like, that one liner that describes like the gotcha moment or the pattern that you used to do the problem, and then you kind of organically branch out from there, like from that like short high level description of how the solution works, then it's much more organic. It's much more scalable for you to remember these things. And then it also gives a much better signal for your interviewer, because like it actually shows your brain working through how to convert like these concepts into a functional solution. Yeah. Rahul, anything to add here?
Yeah, I think the third bullet point in particular, I really like that. And I know Alex has used it to great success, and I've also been experimenting. I like learned about this from Alex actually, and been doing it. And I think that this idea of tolerating discomfort for a little bit longer periods of time, in many instances, that insight, like that ability to tolerate discomfort, that is the key to success. So rather than viewing it as a binary thing of, okay, I'm trying for the problem for 5 minutes and then I'm going to give up and look at the solution, I really think that figuring out how to get a hint from the interviewer, or maybe looking at the first couple sentences of the problem solution and then going back and struggling again, that really is where a lot of the learning will happen. So I think whatever system you come up with is probably going to work, but just be diligent about, not completely flipping over to reading the solution. Give yourself an opportunity to struggle.
Yep. And then to kind of clarify these concepts, we have a very concrete example with twosome, which is a very, very commonly used interview problem. It's quite famous, to the point I recently learned that Stanford has published like a little explainer on just twosome. Like they have like a 5-page PDF just walking through twosome in depth, which is interesting. But so this is an example of like how you should not remember the solution to twosome, which is the actual code, because like we don't think, this is so far from English, right? Your brain doesn't think that way. Your brain doesn't think like, oh yeah, private Boolean sums to target. This is not naturally easy to remember. So if we go to the next part, how you should remember the solution to twosome is, this is essentially that one liner that explains like the essence of the problem, which is like you look for the difference from like the elements within the array, and then you use a hash set to see if you can find that difference later on. So if you're trying to get the twosome of 9 and then you see 3 in the array, you should look for 6 somewhere later down the line, which is 9 minus 3.
And this is really the essence of maturity, or becoming better and better at some skill. If you think about any skill, not just interviewing, but the sign of growth is the levels of abstraction that you're dealing with are higher and higher. This is a really good illustration, right? Like that top, like the actual lines of code is a fairly low level of abstraction. Like you're talking directly to the computer in lines of code that the computer can understand. Like there's no ambiguity. But then this one liner, which is the essence of the problem, the essence of the solution, look for the difference and use a hash set. That is now operating a little bit higher level. Like there might be some more ambiguity, but like if you're a decent programmer, you can probably fairly easily turn that into code. And so like you can kind of extend that beyond interviewing, but the idea is that when you start becoming comfortable with larger and larger building blocks, you can achieve much more, and you're also going to be able to do things much faster. And that's kind of the core idea here.
Yep, for sure. Yeah. So moving on to the actual mechanical part of doing the interview, with the first core concept being communication. So this is what sets apart, I think, big tech interviews in particular, is that the communication is weighed a lot more heavily. So there are probably a lot of places that give DSA problems, and then if you get the right solution, you'll almost certainly get the green check, get a thumbs up, even if you're completely silent the entire time. This is not the case for big tech interviews. So Rahul and I have given lots of interviews at Facebook. We are trained extensively on how to get good signal on the communication abilities of the candidate, and this is because a big company has a lot of people, and in order for you to interact well with lots of people on these, pretty much every project you work on at Facebook is going to have so many different stakeholders. You need to be able to communicate well. You need to be able to build these relationships, to communicate your point in a clear way and be respectful of other people's opinions. Like if you don't have strong communication skills, you cannot survive in big tech. So big tech explicitly looks out for this during the interview. So some like extra thoughts here is, yeah, as mentioned before, when you're doing your DSA round or just any round in big tech, you're not only getting judged on the quality of your solution and whether or not you got the right answer, you're also being judged on your communication skills. And at Facebook, it was essentially like a completely separate axis on like how we weighed candidates. So yeah, don't just kind of be heads down and yeah, you get the right solution, but then you're completely silent the entire time. That is probably not going to get you that pass. And just as a rule of thumb, I think if you're silent for more than 5 minutes, that's probably a bad sign. This is a more conservative number too. Like when I was interviewing folks, if they were silent for like 3 or 4 minutes, I also thought that was like kind of weird. You should pretty much be talking almost the entire time. Like you should be explaining like your overall approach. You should be explaining the code you're writing. You should be letting the interviewer, like plugging them into essentially your thought process.
Yeah, I think there's another reason why big tech in particular cares a lot more about communication. And that's because when you enter into a company like Microsoft or Google, you're going to be essentially in a bubble where the technology, the version control, the code review system, almost all of that is going to be custom for that company. They're so big that they've basically invented new languages, new frameworks, and you're going to have to learn all this new stuff. And so what they're trying to judge in these interviews is not, can this person code, but can this person communicate ideas? Can they take a concept and deconstruct it in a way that I can understand, or hopefully in the way that they can understand if there's some back and forth in the interview, right? And so that requires a little bit more difficulty compared to a small 5-person company where you're expected to know Angular 3 and you're going to implement a feature using Angular 3 and some CSS, right? Like I view those companies as more of hiring commodity coders, like people who can do some particular tooling thing and get it done. And there's not as much emphasis on being able to horizontally apply your skill to another domain. And that is really what big tech is about. And I think correspondingly, they'll also pay more for that adaptability.
Yeah, and then to really illustrate this concept, I have this meme I hacked together for the presentation. I've seen this happen before. It's just really awkward where like the interviewee comes in and they just code and they don't talk. And I just don't know what's going on. And here's the thing about about big tech, kind of alluding to Rahul's prior point, is big tech doesn't really care that much about what you're currently experienced in. Like they don't really care that, oh yeah, with this particular language, with this particular framework, you can create this particular thing. Because as mentioned before, like big tech, they have their own custom stuff and it's always evolving. Like these companies are big and successful because they move so fast. Their adaptability is super, super high. And they expect that from their engineers. And how we reflect this in the interview is we don't try to have them code in a particular language. Like generally with a smaller company, like you care a lot more about the tactical stuff. You go like, okay, we're a Ruby shop. We want you to write Ruby because we want to know that you can write Ruby. But Facebook, and I think all the other big tech companies, they just go like, hey, write in whatever language you're comfortable in. Because like we don't really care about like your explicit tactical knowledge. We just want to care about your adaptability. So what that means is the interviewer is oftentimes judging a candidate writing in a language that they're not very familiar with. Because again, we're trained to essentially give the candidate this flexibility so we can look for fundamentals over experience. So if a candidate is coding in a language I haven't used that much, like I'm actually not, I know JavaScript's super popular, but I'm actually really bad with JavaScript because I'm not like a web or like a node developer. I won't be able to know what's going on if you're a JavaScript developer and you're coding out this complicated JavaScript thing and you're not telling me how your code works. I'm going to be completely lost. It's going to be really hard for me to give you a pass because I don't know what you're doing. Yeah, Rahul, anything to add here?
Quick meta point, totally unrelated. Alex and I have talked about how we want to inject more memes in our presentation rather than just text. So I love this. Alex, I think you did a great job with this meme. I love this cat standing up. If you guys like it, throw us if you want more memes, just give us a reaction on Zoom. We're trying to diversify, make it more media focused rather than text focused. But yeah, I mean, I agree with what you're saying, Alex. It's like there really has to be an emphasis on communication. And I've actually seen cases where the candidate doesn't even get the solution, or they get a suboptimal solution, but I still give them a passing mark on the interview because I feel like they're communicating really well. And if I had given them one more hint, or if we had a little bit more time, they would have arrived at the solution. So that's how important it is at these big companies to really emphasize clear communication and explaining your thought process.
So now we can jump into the process behind the interview. This is generally kind of the thought framework that I follow, and I hope candidates follow if I'm doing the interviewing when they go through a DSA problem. So the first step is to clarify the problem, because as mentioned before, communication is really important. So oftentimes we will give a problem that is actually ambiguous. It's like, maybe 25 to 50% of it is unclear. And we essentially want the candidate to use their communication skills to clarify, okay, exactly what do I need to do in order to satisfy the victory conditions of the problem? Like, do I have to account for this kind of input? How does the data get formatted? Do I need to care about like this particular edge case, like negative numbers or really big numbers or something? So that's super important, in particular, because oftentimes you'll get a problem where it seems really big because it's ambiguous. But then once you actually talk about the interview and be like, okay, what actually do I have to care about in the confines of this problem? It's actually, the scope of the problem is actually much smaller than you initially thought, and it's much more doable. And after you clarify with the interviewer, like, hey, what do I got to do here? You start thinking about the overall approach, right? Going back to the previous slides, think about patterns. So just think about patterns. Be like, okay, can I use a tree? Can I use a linked list? Whatever. And then once you think you're able to get a pattern that works, just let the interviewer know, like, okay, this is my strategy. This is what I think is the essence of the problem. And here's an important caveat here, which is I think something Facebook was really big on. And I remember when Facebook came to UCLA to like talk to us how to crack the coding interview, they mentioned this as well. There's this phrase called "done is better than perfect," and it essentially means that it's better to have something that's kind of basic and probably suboptimal, but it's clean and working. It's better to have that compared to like some attempted 200 IQ solution that is supposedly optimal, but you only got halfway and it doesn't compile. So essentially what you want to do is, for a lot of these harder problems in particular, you're not going to be able to get the optimal solution off the bat like the vast majority of people. You probably have to spend some more time thinking about it and vibing with it before you get that optimal solution. But you'll probably be able to come up with like some relatively simple brute force solution. That's probably like an order of like O of n slower than the optimal one. But you can code it out pretty quickly because it's probably just like a for loop or a nested for loop or something. You can probably code it out in 10, 15 minutes. So if that's the case where it's like, okay, I don't really know what the optimal solution is, and you've been thinking about it for 3-5 minutes, just pitch the brute force solution, code it out quickly just so you have something on the board. As Rahul mentioned, like if you have a brute force solution and you have really good communication, like that in and of itself like might get you close to passing, alongside maybe some progress on the optimal solution. So essentially avoid the step where you're trying to avoid the trap where you're trying to get the optimal solution. You think about it for like 20-30 minutes, and then you just completely blow up and don't have anything working on the board by the end of the interview. That is a guaranteed fail. Yeah. So after you have the overall approach coded out, as mentioned before, it's important that you describe what you're doing. Like, convert your code to plain English so the interviewer knows like what's my strategy. You're like, oh yeah, this line, these lines of code, convert this list into an array or something. I don't know. So they can like follow your code as they go along. And this is essentially also helps you because the better the interviewer can follow your code, if they see a problem with it, they'll be able to help you out because the interviewer isn't just there to like watch you die. Like they want to bring out the best in you. So oftentimes the interviewer just has to give the interviewee a gentle push in the right direction to help them out. And that actually happened to me when I was interviewing at Facebook. Like there were some points where I had like 85, 90% of the solution and I just needed a little bit of a nudge from the interviewer to get there. And they won't be able to nudge you if they don't know what you're doing. So yeah, make sure as you're coding stuff out, just explain what you're doing. Yeah, and then I think the final step is to, after you've coded everything out, analyze the solution. Don't just be, all right, I have the code, I think it works, and then just stay silent. Like actually just go through it. So I think we all know about like Big O notation and explaining the runtime complexity. One thing I've seen candidates forget a lot is space complexity. Like how much space are you allocating? Are you allocating like, a n-sized array or n-squared size grid or whatever? Explain the space complexity as well. And another thing is proactively go through edge cases. So think about how your code can break. Because like in the end, the point of the interview is to figure out if you can write production code. Even though DSA is more abstract, like you can show some behaviors of whether or not you can write production code. And I think a big way to do that is to show that you're really good at teasing out all the edge cases and extreme inputs that can really mess up your code. Because that's going to happen in prod, especially at big tech, which, the scale is enormous and you get weird inputs all the time. You have to make sure that your code can pretty much take in anything and like not die. Yeah. Rahul, anything to add here?
Yeah, I love this. I think a couple things I just want to touch on as well. First off, for clarify the problem, that is so important because some of these companies try and be cute about how they describe the problem. Like I remember a friend of mine was talking about how like the interviewer came in and said, I have a garden and it rains sometimes, and I have these bricks in my garden, and I want you to compute how much water is stored between these bricks. Like, how can I? It was like one of those things where like the friend was like, how can I use JavaScript to help you with your garden watering solution? But it turns out that what the interviewer was actually going for was the trapping rainwater LeetCode problem. I'm not sure if people here have, maybe some of you have probably seen it, but the idea is that you have an array and the array represents the height of a certain like tower or brick or whatever. And you want to see like if you kind of drop water on that, like how much units of water would be stored among this array. And so that becomes way more tractable to actually start to reason about what do I have to do from a coding perspective, right? So I feel like having that open dialogue with the interviewer, especially if they're trying to approach it from like this kind of real world cute perspective, that's really helpful. The other aspect is I will almost always try and say something brute force right away and say, okay, hey, the first thing that comes to mind is this, but here's why I think it's not optimal. And then I start to brainstorm other solutions. The other thing I'll do is right before I actually start writing the code, I will always confirm with the interviewer. I'll say, hey, here's kind of the high level approach. What do you think? Should I write some code? And that checkpoint is a really good way for me to identify if they're happy with that runtime and space complexity of what I proposed, or they want me to dig a little bit further before I start coding. Because the worst thing that will happen is you spend 20 minutes writing the code. That's like the expensive part, right? That's the thing that takes time. And it turns out that the interviewer didn't want you to write that version of the code, or like that was a kind of too trivial or too easy. And they wanted you to actually do something a little bit more nuanced or complicated, right? So you always want to confirm that with the interviewer. And a good interviewer will give you that feedback and say, hey, like, I think what you have is fine, but I think let's talk a little bit more about this. And that's a hint to you that, hey, don't code that. You want to do something a little bit different. And we're talking in this session about DSA, but especially with architecture interviews, which are a little bit out of scope here, but I just wanted to mention that with architecture or design interview rounds, the first two bullet points in particular are the most important because there is no coding, but you need to spend almost all your time in those questions and in those architecture rounds with asking questions. You need to clarify what exactly needs to get done. So you take something very complicated like build the Twitter app. There's a million ways you could take that. You need to clarify that down and to do something concrete and write boxes or draw boxes on the whiteboard.
Yeah. One thing I want to add here with coding the solution, time management is important, which is why Rahul and I gave a session about it somewhat recently. And it's important to recognize that these DSA rounds in particular are a very, very stringent time management exercise. So just always keep your eyes, on the clock. Like, let's say 45 minutes, and you're like 35 minutes in, and you're still coding. Like, if you have any gas in the tank left, use it so that you can like get the solution out, even if it's not perfect, and then you can get to the analysis part. And generally, the interviewer will give you 5 or 10 minutes at the end for you to ask them questions about the company. Some tips on kind of the coding time management portion here is you'll be surprised at how much stuff you can hand wave away. Generally, well, I wouldn't say generally, but a good amount of problems have like portions that are more trivial, like you get your input as like a linked list, and then you have to convert it into like an array or a string or something, assuming it's a linked list of characters. Like those kind of like more utility kind of logic. That's not really important to the core of the problem. Like no one is going to ask you to write an entire algorithm that converts a linked list into an array. Like people know that pretty much anyone can do that. So what I've seen a lot of candidates essentially fail at is they don't do this time management well. Like they prioritize these trivial things that like I don't even care about, and they spend like 5-10 minutes writing them. And that's 5-10 minutes they could have been using to get to the essence of the problem. So like when you're doing these problems, just if you see like these more trivial pieces that are just like, okay, it's a physically like a good amount of code, but it's very simple to write code, it's like very trivial code, just ask them, hey, can I just assume I have this utility method? And oftentimes they'll say yes, because it doesn't really reflect on the core of the problem. So it doesn't give them any signal at all if you're able to write this trivial piece of code.
Right. I'm actually even more extreme than that. I love that advice, but the way I phrased it is like invent the API. And I'm a bit more extreme on it. While I'm coding the solution, I'll tell people, I'm going to assume that this function already exists, and I'll write the function and invoke that function in my main solution. And then I'll say, hey, if you want me to code that up, I'm happy to do that. But for now, I'm going to assume this exists and then move on to the next line of my code. And there's two benefits of that. One is I don't have to get bogged down with something which hopefully the interviewer and me agree is not a good use of time in terms of coding signal. And a second, this is actually good programming practice, right? The art of decomposing a solution and having helper functions, that is actually a good code. Like that's good programming. And so I feel like if you do that, it saves you time, and it's actually like a good programming practice, which hopefully the interviewer will jot down. One other thing I want to mention here is that a lot of people will get nervous around like, hey, what if the interviewer wanted me to do 2 questions or maybe even 3 questions? Although that's kind of rare. Like people are not sure about whether they're supposed to do 1 problem in the 45 minutes or 2 problems, right? And so I think that oftentimes the interviewer won't actually give you that feedback if you ask them explicitly, but that's where reading the body language is really important. And it's a little bit harder to do, admittedly, if you have a Zoom interview, but you can still do it to some extent, where if you see that the interviewer is like pushing you along and like not worrying too much about the specifics of exactly how optimal your solution is, that might be an indication that what you're doing right now is a warm-up question. So you should spend maybe 10 or 15 minutes max, and then move on and say, okay, like what's the next question, right? So I think that's where having that open dialogue, or at least like being able to read the interviewer, is super important. And then the final point I wanted to make here around analyze the solution is that another thing that I have just always done, and I think it's worked out well, is once I have the first pass of the code written, I will proactively say, okay, I've written the code. Let me take a look and just check if there are any bugs. And even if I know there are no bugs, if in the rare occasion where I'm 100% sure, I will still say that just as a way to communicate to my interviewer that I am proactively checking for quality. I'm going to check my for loops. I'm going to check, the edge cases, right? So again, it's like not only a good coding practice, but it's also good communication practice to be able to go that extra mile and like check those edge cases.
For sure.
All right.
I think we're good. I think we more or less did it in cleanly an hour. So
amazing. Yeah. So that was all the main content that we had. What we're gonna do. Let me advance this. So what we'll do now is just 1 minute. Alex and I wanted to mention our next session. Like the whole community here is designed to be as helpful for you as you progress in your journey of building a really successful tech career. That's what we want for all of you. And so, of course, one natural question is, okay, I did the interview, I got the job. how do I now advance my career once I'm in a tech company? And so the next session, which is actually coming up very, very soon, it's on July 21st, which is Wednesday. It's about how to get promoted faster in tech. So mark your calendars. I think Alex might link the direct event in the chat, but would love for you to join here. I think there's a lot of really good insight that Alex and I have had. At least for me, I've been rejected from promo several times, but I've also been promoted several times. So I feel like there's a I think I can share my experience on like what worked for me.
Yep, drop the link in the Zoom chat just now, and I'll share it with YouTube as well. But yeah, promotion is just, it's similar to kind of the content of this session. It's not just about doing the code. It's a lot of it is also about, if you're an engineer anyways, it's also a lot about communication and soft skills and relationship building. And that's essentially